Hi class, today's lesson is about solving linear inequalities. Okay, so today we're talking about, Today we're talking about linear inequalities, and then coming up shortly we will be talking about polynomial inequalities. So this is kind of a stepping stone to that. All right, so a linear inequality, it's basically an equation, but instead of an equal sign, you have a less than or equal to or greater than and equal to sign. So it's an inequality, so that means it's not equal, that is of degree 1. So for example, 5x plus 3 is greater than 6x minus 2. So we need to think about what is different between this, what the differences are between an inequality and an equality. Well, let's think about it. If this was 5x plus 3 equals 6x minus 2, you would only have one solution. You could rearrange and get the one solution that would make those two equal. But 5x plus 3 greater than 6x minus 2 has a whole range of answers that will be correct. So it has a whole ton of different possibilities up to a certain point. So you need to find what that certain point is. So to solve a linear inequality, you find all possible values of the variable that satisfy the inequality. So it's very similar to solving an equation. There's just one other little trick. This is different than a linear equation because your solution will be a set of numbers rather than one number. Okay? So solving a linear equation gives you one solution. Solving a linear inequality gives you a set of solutions. So 3x minus 1 equals 8, for instance. So before you start, think of some examples. So think about what the question is asking. So like if I put 1 into this inequality, does that make this true? So 3 times 1 is 3, minus 1 is 2. 2 is less than 8, so 1 works. What about 10? 10 would be 30 minus 1, 29. That's not less than 8. So how do we figure out the numbers that satisfy this inequality? So what x's will make 3x minus 1 less than 8? So we can think about this algebraically or graphically. Okay, algebraically, you just set up your inequality, and you can actually treat the inequality like an equal sign. So you get that 3x is less than 9 by moving the 1 over, divide both sides by 3, and get that x is less than 3. So that means that all x values less than 3 will satisfy this inequality. Okay, you could also write it as x is in the set of all numbers from negative infinity up to 3, but not including 3, because our original question didn't have inclusion. If we had a number line, we could illustrate this as well. So if we had like negative 1, 0, 1, 2, 3, 4, we could illustrate this on a number line because it's all numbers up to 3, but not including 3. That's why it's an open dot, not a closed dot, and anything in this direction. Okay, so these are 3 different ways, 1, 2, 3, to represent the same solution. Now, graphically, what would this look like? Well, this is just a line, okay, 3x minus 1, and this is just a constant, right? So a horizontal line. So we can graph x equals 8. So did I get 1, 2, 3, 4, 5, 6, 7, 8? Actually, I'm going to go up by 2. So 2, 4, 6, 8. So let's draw a horizontal line then at 8. Of course, that's not quite perfect, but let me move it down a bit. There you go. So there is your line, y equals 8. Okay, and now we can graph our line y equals 3x minus 1. So that would go through a y-intercept of negative 1, okay, and then up 3 over 1. Okay, up 3 over 1, up 3 over 1, up 3 over 1, Okay, and then you can draw a straight line through that point. Oh, that's a huge line. That's pretty comical. Okay, that's too big. Let me get a smaller line. Okay. Okay, so then this line is y equals, sorry, that was so huge, y equals 3x minus 1. Okay, so the question is asking when is the line less than 8? So that would be true for all values. So here is where it's equal. So it's less than, so this line is below this line for all the x values from here over. So if this is x equals 3, then the inequality is true for all x less than 3. So that's the visual understanding of that. Okay, so now we're going to come up to, so what is different solving an inequality versus inequality if you can just rearrange? Well, you can rearrange for the most part just like over an equal sign except for a couple situations. So what are the effects of multiplication and division, addition and subtraction when using an inequality rather than an equality? Use numerical examples to determine the effects. So we're going to start with a known fact. So start with known fact. So we're going to start with a known fact that 4 is less than 8. Okay, so this is our numerical example. So what happens when you do addition? Well, let's say we start with 4 is less than 8, and let's say we add 1 to both sides. Does the inequality hold true when I add 1 to both sides? So 5 is less than 9. Woohoo, we did it. So that works. Now what about subtraction? Okay, so if I have 4 is less than 8, let's say I subtract 2 from both sides. 2 is less than 6. That still works. Yay, we're good. Okay, what about if I multiply by a positive number? So 4 times 3, is that still less than 8 times 3? 12 is less than 24. Yep, that inequality still works. What happens if I multiply by a negative number? Okay, so 4 is less than 8. And what happens if I multiply both of them by, let's say, negative 2? Then I would have negative 8 is less than negative 16. And that is not true. Negative 8 is not less than negative 16. So for this one, we have a problem. Okay, now what about division? Okay, so let's say I'm going to divide by a positive. So 4 is less than 8. Let's say I'm dividing both of them by 4. So then I would get 1 is less than 2. That still works. But what about division by a negative? So 4 divided by negative 1, is that less than 8 divided by negative 1? Well, then I would have negative 4 is less than negative 8. And that doesn't work either. 4 is not less than negative 8. So here's my other problem. Okay, so when you multiply or divide by a negative number, you have to reverse the inequality. Okay, so this always has to happen. So anytime that, so basically you can treat an inequality exactly like an equal sign, except when you're dividing or multiplying by a negative. So for example here, 35 minus 2x, when is it greater than or equal to 20? So first of all, we can visualize what this line would look like. Okay, so let's create a set of axes here. Okay, greater than or equal to 20. So you can create some fake, let's say this is about 20 up here. And what would this line look like? So 35 minus 2x. So you'd be going through 35 and then subtracting 2x. So when 35 minus 2x is greater than or equal to 20, it's going to be from wherever they intersect, whatever x value this is, and it's going to be any x less than or equal to that point, because I can visualize what's going on here. So this is just it's not an accurate sketch at all. I'm just using the fact that this has a negative slope and intercepts above this 20 to realize that I should have x less than whatever number that is. Okay, so if I set up the inequality, 35 minus 2x is greater than or equal to 20. Again, when I'm moving over the 35, that's just subtraction, so I can just still treat this like an equal sign. I don't have to do anything special. But here is where my problem comes in. Now I'm going to divide by a negative, which means I'm using a different color. I'm dividing by a negative. So that means I have to reverse the inequality. So now I have to say that x is less than or equal to 15 over 2. So everything else gets treated the exact same way as it would if this was an equal sign. It's just that because I'm dividing by a negative, I have to reverse the inequality. So this is true for all x less than or equal to 15 over 2. Okay, I use equal to because the question included equal to. Okay, example 4. Now you might have something like this, which is called a double inequality. So 30 to 46, okay? So what we want to do first is just simplify the middle. Okay, so 30, and then this becomes 6x plus 12 minus 2x minus 2 less than or equal to 46. Okay, make sure you're using the distributive property in both cases. So then I'm going to simplify the middle to 4x. What did I do there? Oh, that should be plus 12. 4x plus 10, okay? Less than or equal to 46. Okay, so this double inequality means that whatever you do to one of the 3 spots, you have to do to all 3. So I'm trying to isolate x here in the middle. So that means I have to subtract 10 from all 3 sides. Okay, so that's how I get 20 less than or equal to 4x less than or equal to 36. Okay, so now I divide by 4, and I need to do that in all 3 places. Okay, so I get 5x and 9. So the answer is this, or the solution set for this inequality is that x has to be greater than or equal to 5 and less than or equal to 9. Okay. Now, if you wanted to indicate this on a number line, you could draw a line 5, 6, 7, 8, 9. Okay, you could put 10 on the other side and 4 on the other side here. And you would put closed dot at 5 and a closed dot at 9 because those are included, and then simply connect them. Okay, except in a straight line. All right, so there you have it. Now, visually, what's going on here? Well, visually, I would get to the point where you have the 4x plus 10, okay, and then put it between 46 and 30. So if I go up 5, 10, 15, 20, 25, 30, 35, 40, oh, it's not. Okay, I have to go up by 10. So 10, 20, 30, 40, 50, 60. I'm going to go up 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10. Okay, so I'm looking for my set of my solutions so that it's between 30. So 30 is here. And 46. So that's about here-ish, right? Okay, and then my line is 4x plus 10 in the middle there. So it goes, here's my 10. And when I go up 1, when I go over 1, I go up 4. So when I go over 4, I go up 16. It's still just going to be here. And then here it'll intersect. Okay, so basically I'm just drawing my line. Okay, all I need is a second point. So if I put 10 into that equation, 4x plus 10, 4 times 10 is 40, plus 10 is 50. So I'd be going through 50. So really I can just connect those 2 points rather than using slope. Remember, you only need 2 points to draw a line. Oops, that's not what I wanted to do at all. Okay, there we go. Okay, so there we go. So you can see my solution set then is what's going on in here. From here, which we found to be 5, to here, which we found to be 9, and anything in between. Okay, so this line, 4x plus 10, is between 30 and 46, when x is between 5 and 9. All right, so now I just have some practice questions for you. So try these. The answer you should get here is x is less than 7. The answer you should get here is x is greater than or equal to 7. I like the 7s apparently. Now, and this one, I want to see the graph and the number line. You should get negative 2/3, between negative 2/3 and 4 should be your answer. But I want to see the graph and the number line as part of your solution. Okay, so that's linear inequalities. Thanks for watching, and I hope you learned lots.